Okay, grade 10. We're going to just have a look at how we can use the differences, the first and second differences, to help us work out what. So, we know already that the general equation for a quadratic equation is ax squared plus bx plus c. What we're going to do is we're going to start off with the most general form. So that is that we don't know a, b, and c. This is what we're eventually going to want to find. So if we start off with a table of values from 1 to 6, and to find my y value, I want to substitute x equals 1 into this function. So I do it down here maybe, and I substitute, y equals, now I'm substituting for x, not a, so a times 1 squared plus b times 1 and plus c. So I'm substituting for x, not a and b. They're what we're trying to find. They're constants, so they can't change. Now I can see then, obviously, we just are left with a plus b plus c, which is where this has come from here. Okay, a plus b plus c. Now if I do a similar thing, if I just do one other one to show you, so here x is 2, so I substitute for 2. So I have a times 2 squared plus b times 2 plus c. Now remember, I'm substituting for x because that's the variable, that's a thing that can change. So 2 squared is 4, so I have 4a plus 2b plus c. Hence this is where 4a plus 2b plus c has come from up here. So what we need to do is quickly fill in then when x is 6. So just very quickly, substituting. So we're substituting for x, remember? So I have a times 4 squared plus b times 4 and plus c. So I get 4 squared is 16. So I'll have 16a plus 4b c. Okay. Do the same for when x is 5. So y equals a times 5 squared plus b times 5 plus c. So then I get 5 squared is 25, so I have 25a plus 5b. And then lastly, maybe you can already predict what it will be when x is 6. We have y equals a times 6 squared plus b times 6 plus c. So the last box there is 36a plus 6b plus c. Okay. So these values here are in general what y would be for the general quadratic equation when x equals 1, 2, 3, 4, 5, 6. Now we're going to look at the differences. So if I look at the differences between these two, maybe I get a different color. Let's get green. And we're going to look at the differences between each of the two consecutive terms. So looking at the y values. So here, 4a minus a gives me 3a. So I'm looking at the difference between these two. 2b minus b is just b, and then c minus c is 0. Look at the difference between these two. I have, if I write it out, 9a minus 4a, so that's 5a. 3b minus 2b, so plus b, and c minus c is 0. Next one, look at the difference between these two. 16a minus 9a is 7a. 4b minus 3b is plus b. c minus c is 0. The next two terms, 25a minus 16a will give me 9a. 5b minus 4b is plus b. And again, c minus c is nothing. And the last one. Maybe you can even see the pattern here. 3625a is 11a, 6b minus 5b plus b, and c minus c is nothing. Okay, and let's get a different color. Let's get blue. And now we're going to look at the second differences. So this is then looking at the differences between the differences. So the first one's done for us. We can see 5a minus 3a is 2a, b minus b is nothing. We look at the next two. 7a minus 5a is 2a, and again b minus b is nothing. The next two, 9a minus 7a is 2a, b minus b is 0, and finally, following the same idea, the difference is 2a. So this table here, this first table here, is the general differences, the general results used for the first differences and the second differences for any quadratic equation. So now what we're going to do is do it with an actual example. And so first of all, we're going to find the first and second differences. We already have the y values here. So if I get the corresponding colors so we can refer to it later on. And we just find the first differences quickly. So we have the difference, 9 minus 4 is 5. 18 minus 9 is 9. 31 minus 18 is 13. 48 minus 13 is 17. And 69 minus 48 is 21. And then if we do the differences of the differences, the second differences, then we're going to do 9 minus 5 is 4. 13 minus 9 is 4. 17 minus 13 is 4. 21 minus 17 is 4. So remember, if the second differences are all the same number, this is what tells us that it would be a quadratic if we didn't know this already. Then the fact that these are all constant, the second differences are the same, that tells us that this number pattern must be a quadratic function. Now what we can do is relate the two tables here, because this is the general table, this is for a specific example. So what we can do, if I get my highlighter, oops, let's start from the bottom this time. So we're going to work our way from the bottom, work our way up. If I take the first difference there, the first difference in my second table, and I correspond it to the first difference in my general table, I can see then I have the 4 and the 2a match. If I then take the first difference, I'll take just the first number and the corresponding general expression. So this is the first difference. Here is my first difference. And oops, then lastly, if I take, let's get a green one. If I take my first y value in the general, so this could be any y value for any any quadratic. And there is the y value in this particular case. So what we're going to do is we're going to find some relationships and work out what A, B, and C are. So let's get red. So what I can say here, my second difference is 4, and that corresponds to the general expression that it's always, for a quadratic, the second difference will always be 2 lots of A, where A is the number here, the number in front of the x squared. So what I must be able to say then, if I just move this up, oops, come on, let's try again. Oops. So what I can say, let's get the pen back. here is that 2a, because that's the second difference in general, must equal 4. And then we can see, obviously, a must equal 2. So we know for this particular number pattern, the number in front of the x squared, the coefficient of x squared, must be 2. If we set up two other equations, I can see my first difference, if I take just the first number, the difference between the first two terms is 5. If I go in general to the general quadratic, the first difference is 3a plus b, so they must be equal. Plus b must equal 5. At the same time, I'm going to then do the same for the green one. So for the first y value in this case, you always have to choose the one that corresponds. So here I'm choosing when x is 1. So when x is 1, y is 4. In general, when x is 1, y is a plus b plus c. So again, I must be able to say a plus b plus c must equal, the matching green one must equal 4. Now, if I go back here to this equation, this expression here, I know a is 2, so I can substitute 2 in here. So I have 3 times 2 plus b equals 5. 3 times 2 is 6, so therefore b must equal -1. Okay. Now here, I know what a is now, and I know what 2. So 2 plus b, but b is -1, so 2 minus 1 plus c equals 4. And we can see that c equals 2 minus 1 is 1. So 1 plus something gives me 4, so c has to be 3. So now I have my a, b, and c. So what we can actually say then up here, that the rule, the pattern follows the rule. A is 2, so it must be 2x squared, b is -1, so minus x, of course you can write minus 1x, plus c, so plus 3. And this is then how we can use a more formal algebraic approach if it is a quadratic equation. Okay, hope that's some help. Bye.